Hi everyone, and welcome back. In the previous video, we discussed the S3, which is obviously behaving as a data lake for this tutorial. And we have seen that how we can store unlimited data in a proper structure in the S3 buckets. And now we're gonna see another amazing service from AWS that will help us to interact with that data, which is now sitting in the unstructured format within our data lake, right? So if we look at the architecture, obviously we discussed the S3 bucket where we are going to get our data, and now we are focusing in this video on the AWS Athena. Athena is really a great service. It's based on the Presto, which has been built obviously by Facebook, and AWS has built the serverless Athena service to interact with the big data without going deeply in the arrangement and configuration. You just need to set up your catalog, which is obviously going to be configured within the Glue, and we'll discuss Glue separately. But in this tutorial, let's our focus be on the Athena. So in Athena, you can set up your database and your table, which is more like a skeleton, because that will just contain the metadata information. Because later on, once you issue the query, Athena won't store any catalog information. That's gonna store in the Glue, right? So within Athena, it just have a reference to the Glue service where it goes and get the information, which is obviously metadata about our table, which we are going to interact with, and then it extracts the data. And in this case, because our data is stored within the S3 bucket, so the table we're going to create, whatever reference we'll provide, including the schema, that will store in the catalog that is based in the Glue, right? And we're going to see in a moment once we run these queries, right? The concept of creating the database and then the table and the view is exactly, the similar, going to give you a similar environment that you are used to from last, I would say, 10-20 years, if you haven't interacted with the unstructured data in the big data world, right? Or if you are coming from the relational data environment, right? Athena assumed that you will your learning experience or your work experience with this service will be seamless, and you're not gonna face any difference whether you are interacting with the database environment or the non-database environment, right? So by discussing it, let's jump back into our AWS environment, and what I'm gonna show you now, you can see I've already in the AWS in Athena console. But what I'll do, let me just move on to the front page. So once you open the Athena, and if you are unable to see on your console, you can just go and search it. And in Athena, once you come into Athena, because I've already opened it, so that's why it is bringing directly towards the query editor. But what I'll do, I'll just go to the landing page, and in the landing page you can see we have the query your data with Trino SQL, and that is, like I mentioned, because Athena has been developed on top of Presto, so it's actually inheriting all the tools and the query engine that has been used as part of the Presto, right? And Presto obviously built by the Facebook, and they later on outsource open sourced it for the community, which is a great thing. But now you can see we got the one thing, if you look at it now, we can also use the PySpark and Spark SQL to interact our data. So it's more like, we are working in the Databricks environment, but obviously that's a completely AWS flavor, right? And I'm going to show you later on, or even you can think of, we are working with the Synapse in Azure, but obviously we are working within the AWS environment, right? So different companies are now offering different services for the same purpose, but in this tutorial we're going to focus on Athena. All right. So now let's move on. The front interface, you have some pricing calculation, and you can see SQL queries which you issue. They're going to be charged based on the the data that has been scanned from the S3 bucket, and you can see the charges are based on the per terabyte, which is $5. And I would say it's a really reasonable price, and that will also limit the issuing of the queries and making sure that we know what we are doing, instead of in our local environment where there's no charges, but people issue queries without realizing what's going to happen on the server end, right? And obviously we have a cost calculator. We're going to see in future how that calculator works. But with Athena, like you can see, it's pretty smooth. Like you can just point your data source. So that's what we have done in our first video. We created our data source, and now we are in Athena. And in Athena, we're going to do, because we are going to issue the query. But in order to do that, we're just going to create a couple of wrappers before we can interact with that data, right? Because we are issuing the SQL queries. So to work with SQL's the environment, we need to do a couple of steps. All right. So let's go, and you can see on the right hand side we have query editor, we have notebook editor, and notebook editor we're gonna see in the last video. That's a very powerful concept. Like you can see, analyze your data using PySpark and Spark SQL. Like you can write down all the notebook code like you normally do in the database. If you don't want to purchase another tool and you want to just be a vanilla environment from the AWS perspective, so now you don't need to complicate your architecture or environment by introducing more and more tool. With Athena, you can literally write down your notebook that can prepare your data, and it can push the data from one stage to another, right? So that's a completely different world from the analytical perspective, which we are gonna see in the upcoming tutorial. So in this video, our focus is on query editor. So let's jump into the query editor, and you can see I've already issued a couple of queries. So what I'm gonna do, excuse me, I'm gonna let me just take this one out. I don't want to. So in order to work with the S3, we're first going to create a database which will put a wrapper for us, because we are going to contain the metadata, and that metadata needs to be stored within some sort of container, which in our database languages we generally call database. And then even under the catalog we have the database, and within the database we have schemas, and under the schema we have table views and all other database objects. That's a I would say established norms in the database community. Don't need to debate on it, right? So it's just a process in order to interact with the S3 bucket, right? We are going to create a database, and by the way, that just contain the metadata. It's not going to store any information from the data perspective. It just store the metadata, and metadata is data about the data, right? And if you don't understand, I've already published an article on LinkedIn. You can go and check that article to understand the concept of the metadata and as well as the reference data. All right. So let's create. The command is pretty simple. You can see I'm just issuing the command create database and the database name, because it's not going to store any data file like traditional databases. So that's going to be pretty smooth. Let me just click hit running. And by the way, you can if you scroll down, you are gonna see the run button, and run will once you click it, it's gonna execute the command or the script that you have put in the editor window, right? And the command is successful. We have seen the messages in here, and you can see my now database box has been filled. One thing I want to show you in here, if I quickly go to my Glue environment, and Glue, you can even type in here. AWS Glue is the ETL tool, very powerful tool, which I would say based on the Spark, and it will provide the ETL capabilities which is amazingly powerful, right? And it's a serverless data integration service that you can use to move your data from source to destination. We have many use cases of it. Glue. It's pretty mature service we're gonna see in the future. But let's hit AWS Glue. And one thing which I want to show you, you can see the data catalog. Like I mentioned, the catalog only stored the metadata information that Athena used to find out where it's going to actually get the data as part of the outcome of your query, right? So if I come in here, you can see the very first thing we have seen, it has the database, and that's our database which we have created. You can see AG customer. If I come in here, we don't have any table, which is fine because I haven't created any table, but you can see where I have once I issue the command, even from the query editor, where the database base has been created, right? So don't forget, once you issue the command in the Athena, it won't create anything within the Athena environment, because Athena interact with Glue to get the metadata information about our object, which is in this case is going to be database and the table. All right, so our database has been created. As a next step, what I'm going to do now, create a table. And if you remember, if you actually shown you in the last video, that's our CSV file, and you can see it has bunch of field. Let me just, what I'm gonna do, split it into two line, and later on I'll bring it back. So you can see it has bunch of columns which are part of schemas. And now we are going to create a schema based on these columns, because obviously we are going to interact this CSV file which has been stored within S3 environment. All right, so if I jump back, so you can see I have created a table with the create external table. If it doesn't exist, I just run it just to check, make sure my statement is not going to fail. A very quick way to check whether the table exists or not. So the convention is I put the database name dot table name. So you can see AG underscore customer, that's my database. You can see on the left hand side as well. And then after dot, I'm gonna put the table name, which is TBL AG underscore customer, right? And then that's the full schema. You can see it start from first name, middle name, last name, age, city, country, date of birth, postcode, address, phone, email, and created date and last modified date. And by the way, if I show you quickly in here, that is exactly aligned with this schema which I have seen in my CSV, right? So you can look at the CSV and you can define your schema based on your CSV. Now we have here two options. We can give it a journal data type, like store everything into Varka, which will avoid any data issues, and we are able to load all the data. If we are loading, for example, in the landing zone, where we're going to actually stage the data by looking at the health of the data, and then convert it. But because we are already keeping the original file in the S3 bucket, so that's why I think I'm good with the landing stage. I don't need to redo the landing process here, because my data in its original shape is already stored right into my S3 bucket. What I'm going to do now, I'm going to now change it to stage it to make sure the data types are correct. So you can see for age, I know it's going to be integer, numeric, date of birth is going to be date, and the created date and last modified date is going to contain the timestamp when the record has been created, right? And that is all coming from my source file, which is the CSV. The rest is obviously going to be textual information, so I'm using the varchar. I'm giving it the length of 100, which I believe is going to be suffice for this exercise or for this data set. And then we have bunch of option which define some I would say additional options for this metadata information that is going to be created in the catalog as part of this table schema information. And you can see some of them like field delimiter, and you can see because I'm using the CSV, so field delimiter which is going to separate the information is going to be comma, and the input format is going to be text input format. And then I'm also providing the most important thing. I'm providing the location, and that's where it's the glue is more like, gluing the two services together. You can see I've already provided my S3 location, which is the bucket name and the folder, because I'm only reading from this folder. Right now, it will also give you the idea that you are going to set up multiple tables based on the different folders within the same bucket, right? So for your, I would say one bucket is more like a database where you can create multiple tables, which generally we do in our database environment. But in our S3, or I would say in our data lake environment, that's going to be the folder structure, right? And each folder generally represent a table, and underneath we have multiple folder, and that's based on the partition of the information, how we are partitioning the information based on our partition scheme. And obviously that's going to be the architecture concept, and that really help us from issuing the query and getting the response quickly. Right, so these are all the discussion about the designing and architecting our big data platform. But just to give you a quick idea that to how we are linking our table with the S3 location, right? And obviously the table property classification is going to be a CSV. We can also interact with the JSON, Parquet file on ORC. There are multiple formats available, but at this stage we are good with the CSV file. So now let's hit run to see whether it's going to create the table or not. And if we look at the right hand side, awesome, we have got our first table created in the Athena. But remember, this table is not created in the Athena. This table has a reference in Athena, but I'm going to show you before I conclude this video. This table has been created in the Glue. And with the beauty in this architecture, Glue is only retaining the metadata about this table, and it's gonna provide that metadata back to Athena once we issue the queries, right? So that's the whole interaction between multiple services that we are using in this tutorial. So our table has been created. We have seen the table metadata has been created in here, and the next step, now we're gonna start interacting with this table using a plain SQL commands, right, which I'm gonna do in the next video. Feel free to put any comments if you have any question. Otherwise, I believe you're gonna like this video, and I'll see you in the next one. Thanks for watching. Stay tuned.